In this video you'll learn how to do node voltage analysis. So as you can see, I've got my circuit laid down here. It's got 4 resistances and 1 voltage source and 1 current source. So in node voltage analysis we make use of KCL and Ohm's law to solve our circuit. And KCL states that the algebraic sum of currents in a network of conductors meeting at a point is 0, so which basically means that the sum of all the currents entering the node and exiting the node should be 0. As you can see, at node 1 we got minus IS going to the right, I10 going to the ground through RA, and R12 going to the left through RB. So we know that the sum of these currents must be 0. And now similarly, when you take a look at node 2, we got I21 going to the right from node 2 through RB, and I20 going to from node 2 to ground through RC, and I2D going from our node 2 to VS. So we also know that from KCL the sum of these three currents should be 0. Now we'll take a look at the circuit with some values and try to solve for some unknowns. Okay, so we have a circuit here. We have 120 volts as our voltage source, 10 ohms resistor, 10 ohms resistor, and 40 ohms resistor, 30 ohms, and 8 amperes going up into this node. So we're given to find the voltages V1 and V2, which is here. So we know KCL, that the current entering the node and the current exiting the node, their sum should be 0. So what we can do from KCL and our Ohm's law is that we can make two equations to solve the circuit. So if you look at node 1, what happens is that using KCL, current entering here, current going down here, and current going to the left of it, the sum of them should be 0. So we do 0 equals V1 minus V2 divided by 10, which is the current going this way. Okay, V1 minus V2 divided by 10 plus the current going downwards to the ground here. This is the ground. That is V1 minus ground, which is 0, divided by 30. And finally we have 8 ohms coming in, so we just do minus 8. I want you guys to remember this, that whenever we have a current going into the node, we take it as minus. And whenever we have current exiting the node, we put the sign as plus. So since we have 8 amperes going into this node, we take it as minus 8. So this is actually Ohm's law, because we're taking the voltage across, let's say V1 minus V2 by 10, which is V1 minus V2 by 10, which is the voltage across this divided by the resistance, since we know I equals V by R. So here's our first current, our second current, and our third current, which is just a negative of minus 8 amperes. Okay, so if we go ahead and rearrange it, we get 0 equals 4V1 by 30 minus V2 by 10 minus 8. This is our first equation. Okay, and now for our second equation, because we need two equations to solve our circuit for V1 and V2. Now we take a look at node 2. At node 2, what's going on is that we have, even here we have 3 currents. One to the left, we assume it's going left, since there's no direction given. And another current coming downwards from node 2 to ground. And just ignore this arrow which we drew earlier for node 1, and let's say there's another current going to the right. So at node 2, also we have 3 currents, from to the left, to the ground, to the bottom, and to the right. So looking at from node 2 to node 1, our current would be 0 equals, now using KCL and Ohm's law, V2 minus V1 by 10 for this current right here. Now plus for this current right here, V2 by 40. And for the current going from node 2 to this voltage source, we just take it as V2 minus whatever the voltage it is here, and that'll be V2 minus 120 by the resistance of 10 ohms. Okay, so since there's 120 volts voltage source right here, we do V2 minus 120. So you might see some other questions where this is flipped and it is actually the minus is over here on top and the plus at the bottom, so you don't need to panic on that. You just do V2 minus 120 divided by the resistance here, so that'll actually be V2 plus 120. So that would be a little trick question which could appear in your homeworks or exams. So for this circuit, if we go on and do the algebra over here, we will get 0 equals 9V2 by 40 minus V1 by 10 minus 12. Okay, so we got our equation 2. Here's our equation 1 and here's our equation 2. So now we can go ahead and do our matrices to solve these two equations, and I hope you guys already know how to do the matrices. Here what I've done is just put it in a form so you can solve for V1 and V2. You could either do this way, or you could just plug these two equations into Wolfram Alpha and it'll give you the values for V1 and V2. Okay, so now I've typed my two equations into Wolfram Alpha for x being V1 and y being V2. So as you can see, it's giving me x equals 150, which means our V1 equals 150, and y equals 120, which means V2 equals 120.